Okay, so today we're going to work on graphing radicals. So we did quadratics and we gave you the shape, and then we did H and K and moved it all over the place, right? Then reciprocated it, made it wider, made it narrower. Guess what we're going to do? Same thing. We're going to give you an H and a K, and we're going to make it wider, we're going to make it narrower, and we're going to flip it around. And so...
Yeah, Ms. Mick, I did not understand any of that when you did it the first time.
So graphing, this is the parent function. Y equals the square root of x. So we're going to start by just graphing it. If I told you to graph it, do you know what it looks like right now? No? So if I told you to graph something and you didn't know what it looked like, how would you graph it?
Don't.
Please, Alex, helpful or don't say. If you needed to graph this and didn't know what it looked like, how would you graph it? Can I plug in an X and get out a Y? Couldn't I do that? Revert back to like 8th grade math, 7th grade math, right? So get, ooh, that was horrible. We're going to make an XY chart. Okay, the reason why I want to learn what a graph looks like is because I absolutely hate XY charts. They're annoying. I hate drawing them because then it's not straight, and then I want to redraw it, and it just, my brain is too much. So I have X and I have a Y. Okay, so this is a square root, yes? Can I put a negative number in a square root?
No.
No. Okay, so that's not even in my domain, is it? What's the first number I can take a square root of? Smaller.
0.
Can I take the square root of 0?
No.
Yeah. What is the square root of 0?
0.
0. So I can do that, yes. But can I take the square root of negative 0.000009?
No, because it's a negative.
No, because it's negative. So 0 is the first thing I could do. And we're doing square roots, so we can pick good numbers, right? What's a good number to put in a square root?
1.
1. What's the square root of 1?
1.
1. We're just putting it into this equation, right?
Yes.
Okay. What's another good number?
2.
2? You know the square root of 2?
4.
4. Because the square root of 4 is 2. I don't want to have to graph, like if we did 2, it'd be the square root of 2. Do I want to graph the square root of 2?
No.
No. I know it's bigger than 1, less than 2, about like 1.2, but I don't want to graph that. What's another good one?
9 and 3.
9 and 3. Well, this graph only gives me 0 to 10. So is there any good numbers between 0 and 10? More good numbers? No. What would be the next good number to use? There's
16.
one, 16. 16, 25, the perfect squares, right? Okay, so 0 is 0, yeah. Let's plot those points. 1 is 1. 4 is 2. 9 is 3. If I had 16, it would be 4. It'd be clear up there, right? What's it look like? What do you think it looks like?
A curve.
And it's going to keep going. If you turned it this way, it'd look like half of a what?
Parabola.
Circle.
It would look like half of a parabola, wouldn't it? Look. Yeah?
Oh, the parabola's around.
Why does it make sense that a square root looks like half of a parabola? What equation gives you a parabola? X to what power?
1/2.
No.
Oh, 2.
X squared, yes? So if x squared gives you parabola, well, the square root of x squared would be x. So wouldn't that make sense that you'd have half of it? Yeah? Okay, so this is what the parent function looks like right there. What's the domain? What we can put in it, right? Could we put anything negative in it? No, where do we have to start? 0. So x such that x is greater than equal to 0 in interval notation, or I could be bracket 0, infinity, right? What about the range? What's the smallest range? What's the smallest y value? 0. What's the biggest?
3.
Well, does it stop?
No.
No.
To infinity?
Infinity. So y is greater than equal to 0 or 0 positive infinity. Either way you want to write it. So when we move this around, remember when we moved around the parabola, we moved around 0, 0, didn't we? So guess what we're still going to be moving around? 0, 0. We're going to be moving this thing everywhere, all sorts of things. So when I ask you what a square root looks like, you are looking like that. Kind of reminds me of a square root, doesn't it? Like a radical sign. A really poorly drawn radical sign, but could it?
Mm-hmm.
Yeah. So when I say parabola in your head, do you picture this? Should you picture that when I say parabola? So when I say square root, you should picture what? That. Now, when I change the number out here, it's going to change whether it's big or whether it's small, right? Correct? So this is going to be like from 0 to 1, because it would be taking a fraction of the answer, right? And this is going to be greater than 1. So what happened in a parabola when I made a large? It got narrower, didn't it? Did it get narrower? Okay, this is kind of opposite, isn't it?
Mm-hmm.
Okay, and then it got wider. So let me see. I think I have other things written down here. Oh, okay. So, I didn't ask you. Was the other function increasing or decreasing, guys?
Increasing.
It was increasing. It was going up, right? Okay, so I need to graph 3x. So what do I need to make? A t-table, right?
Sure.
Now we know it's going to look like this. Yes? Do we know it's going to look like that?
Mm-hmm.
What's the first point you want to go to? What's the first x you want to put in?
Yeah, 3.
How about 0?
Fine.
I gave you that hint. What's the main point we're going to be moving around, guys? 0, 0?
Mm-hmm.
Okay, so 3 times 0, 0 square root of 0 is
0.
0. Now, Sam says she wants 3. Why do you want 3, Sam?
Because 9 is a perfect square.
Because 3 times 3 is 9 and it's a perfect square. So I get 3 times 3 is 9. Square root of 9 is 3. What about... What about 4/3? Why did I pick 4/3? 3 times 4/3. What's that going to be? The 3 is reduced, yes. And the square root of 4 is 2. Now, the y is good. Is the x good? No. And this actually would be in between those two, wouldn't it?
Mm-hmm.
9/3. Well, 9/3 would just be what?
3.
Well, not 9. Yeah, 9/3 would just be 3, which... Is there another number you want to put in there?
12.
9.
Well, 12 would be... Okay, so if we did 12, it'd be 36. If we did 9, it'd be 27, and 27 is not a perfect square. So if we did 12, we get 36. Square root of 36 is 6. 16 thirds. Can we do 16 thirds?
Yeah.
It'd just be 16 and now do it all.
So 16 thirds would be 16, so it'd be 4. So that means that's right in here. Right? Now, I'm coming up with numbers. Are they good numbers? Not really on the x side. Are they good numbers on the y side? Yeah. Okay, so let's just graph what we have. 0, 0, that was easy, right? 3, 3 was easy. 12, 6, but 12's clear out here. So it's like up here, isn't it? Okay, so 4 thirds would be 1 1/3, right? So that would be 2. So somewhere like there. Does that work? 16 thirds would be what?
Like 5 and something? 5 and
5 1/3. So 5 1/3 is 4. So does it basically have the same shape? But what is it now? The other one was down here. What happened to this one? If you think about against the x-axis, it got wider, didn't it? What made it wider? What made those numbers bigger? That 3, didn't it? Is it increasing or decreasing?
Increasing.
Increasing. What's my domain?
X such that x is greater than 3.
Mm,
Greater than or equal to 3.
x. What's your
0.
0? So x such that x is greater than or equal to 0. I didn't move it left or right, did I? So if I'm not moving it left or right, is the x going to change? No. What about the range? Did I move it up or down? Nope. So it's still going to be y is greater than
0.
and equal to 0. So do you see that like the same stuff we've been doing is coming back around? Hopefully it will prove a little bit better every time. So what's going to happen to this one? Using our rules that we've had before, what would you say this is? It's a variable that you've noticed before. It's grouped with the x, so it's a what?
H.
It's an h. What do h's do? Move it what way?
Left and right.
Left and right. Okay, so the parent function, let's write the parent function so we have it down. So it would be plus or minus a, the square root of x minus h plus k. Now the book will sometimes put the k in the front. They'll write k plus or minus a, the square root of x minus h. Does it matter? No. So h moves it left or right. K moves it what?
Up and down.
Up and down. So the original parent function, I don't want to make a table. Do you want to make a table? No, I don't want to make a table. I want to use what I know. So the original function started at 0, 0, and it went like this. Yes? Okay, so where is this one starting? It doesn't start at 0, 0. What's this 5 do to the graph? Move it to the
Right.
right 5. So it starts at 0, 5. Is there any other changes I have there? No. So instead of starting 0, 0, it's going to start at what? 5. And remember at 1, it was 1. So now, not at 1, it's going to be 1. At 6, it's going to be what? 1. Get what I'm doing? At 4, it was 2. It's not going to be at 4 anymore. That's going to be clear over at 9 is going to be 2. Do you see how these points are changing? I should have done them in a different color. Please communicate with me, guys. You're just staring at me, and it's getting kind of creepy. I put my orange dot the wrong place, didn't I? Put it 10. Do you see how that graph just moved over?
Yeah.
Actually, my first curve was pretty good, wasn't it?
Is that supposed to be 0, 5 or is it 5?
It should be 5, 0. I wrote 0, 5. I graphed it correctly. Thank you, Sam. Because H would be first, wouldn't it? It's been a day, evidently. So did we have to make a table? No. Knowing what it looks like gives us a graph, doesn't it? Now, you're not going to have graph paper, so are these going to be sketches?
Mm-hmm.
Questions? Are you having flashbacks of parabola graphing?
Yeah.
Good. I want to get away from PTSD, but I want some flashbacks at least.
This is what we're doing today.
Okay, so this is what we just wrote. Yes. Okay, this is what we just wrote, is it not? So we have f of x equals a, the nth root of x minus h plus k. We are only going to do square roots. Do you think this applies for every root?
Yeah.
Yes. I will tell you every even root, before it is done anything with, it looks like what we just sketched, except for like this is square root and this is fourth root. Why would fourth root be smaller than square root? Because you're breaking it up into what? Fours. So the smaller the root, the closer to the x-axis. Make sense? Now, if I was doing an odd root, can we take the cube root of a negative number? Yes, because that would be 3, right?
Mm-hmm.
So could we take an odd root of any negative number?
Yeah.
Yes. So odd functions look like this, which just looked like the square root, yes?
Mm-hmm.
And then the odd part of it goes where? Does that make sense why it does that? Because we can take the negative root. So this is an odd. Oh, that was interesting. We are not going to do odd because we just aren't. But odds look like the even plus this. So this is odd. And our evens look like what? And why does the even only have one part and the odd have 2? What is the odd? This is the cube root, the 7th root. Well, because I can have a negative answer, yeah? So since I can have a negative answer, I can put a negative in, so that gives me the negative part of the root. Does that make sense? So again, A determines the stretch or compression. There should be a plus and minus out here because we can reflect it over the x or y axis, correct? Okay, H moves it left or right, K moves it what? Up or down. So it says graph, so we need to go through this. So 0, 0 is our point that we're moving. So I have g of x equals 3, the square root of x plus 3 plus 5. So 0, 0 is moving to where? Well, this is our h, and this is our k. So the formula says negative, and this is a positive. So how did a negative become a positive? It was a negative. So h and k is negative 3 and positive 5. So that means I have to subtract 3 and add 5. So what's 0 minus 3? Brandon, you could at least watch. What's 0 minus 3, guys?
Negative 3.
Negative 3. What is 0 plus 5?
5.
5. So this graph isn't going to start at 0, 0, is it? It's going to go back 3 and up. And it's going to start right here. Now, is this going to be wider or narrower because of that 2? It's going to be fatter, isn't it? There's an imaginary x-axis up here. See that? Because I moved it up. So am I going to be close to that axis or further away? Every answer I get out of the square root, what am I doing with it? multiplying it times 2, not itself, we're not squaring it. So is it going to get further away from that new x-axis or closer to it? If I'm multiplying by 2, it's going to get further away, right? So I'm just going to graph it a little bigger. Is this an exact science?
No.
No. But if I have a 2 for the A and a 1 for the A, should the 1 be closer to that x-axis? Yes. I'd like to know why I'm getting blank stares from half the people in the room. I'm really curious. Am I good to go to the next one?
Yeah.
Okay, so what's going to happen with this one? This is a half. So I'm not going to get further away from that axis. I'm going to get what? Closer. Okay, so what's my H? 1. What's my K? -3. So 0, 0 is going to go to where? +1 minus 3. So it's going to go to where? 1, -3. Correct?
Mm-hmm.
Bless you. I should not have drawn it like that. So +1. So here's my vertex, basically, right? And now the new imaginary axis is where? There. So it's going to be what? Like that?
Mm-hmm.
Are these that hard to do?
Mm-hmm.
No. You have to figure out your what? Your H and your K?
Mm-hmm.
Am I good?
Yep.
Okay, how can we rewrite the following radical functions to identify its transformation? Well, we have the square root of 9x. How can I rewrite that?
3 squared.
Well,
Or just 3.
3 square root of x.
Yeah.
So if I were to graph that, the parent function's like this. Yes. What does that 3 do to it? Is it above or below the parent function?
It's above.
It's above, so it would be, because we're multiplying it times 3. That might be over exaggerated, correct?
Mm-hmm.
But is that okay?
Yeah.
Yeah. Okay, if g of x equals the square root of 4x plus 16 plus 7. What's weird about that one?
It has 2 different H's.
Say that again?
It has 2 different H's.
It appears it doesn't have 2 different h's, but we have this. Yes? Is this 4? That's what you're talking about, right? When you say 2 different h's.
Let's talk about the 16 and the 7.
Oh, well, the 7 is the k, because it's out.
I thought it was underneath.
No, that is why you close your radicals, guys. Okay?
Can't you just take the square root of 16?
Well, okay, so we have 4x plus 16. We can't take the square root of them individually because it's addition. But what can I do with 4x plus 16?
Take out a 4.
I can factor out a 4. So I have the square root of 4x plus 4 plus 7.
Mm-hmm.
So what's the square root of 4?
2.
2. So we actually have 2, the square root of x plus 4 plus 7. So oh, thank you.
Yep.
So I think those are invites for prom. So where does 0, 0 go on this one? What's that negative? What's that positive 4 mean? The 4 was what?
One's negative.
One's negative because the formula is negative. Remember that H, guys, is the opposite sign? Remember doing that?
Yes.
So it'd be -4, and what's your K?
7.
7. So if I come over here to this graph, I got to go to -4. 1, 2, 3, 4, and up 7. I just don't want to make another graph. And then I'm going to shoot off. Am I going to be close to that new x-axis or far away from it? Closer or further? Further. Now, it's not as far as the 3, is it? Because this one was 3. The 3 will be further, but the 2 is still further away than the regular. Do you see how we rewrote it without really, like, we didn't change it, did we? No? Did we make it a lot easier to graph?
Yes.
Yes. What is the domain and range of this one?
Which one? Oh,
What's my smallest x value now? Was 0, right?
yeah.
Where's it at now? What's your smallest x now?
-4.
-4. So x is greater than or equal to what?
-4.
-4. What's your range? What's your smallest y value?
Seven.
7. So where did -4 and 7 come from, guys?
The H and the K.
The H and the K. Is it all tied back to the H and the K?
Yes.
Yes. Isn't this amazing?
Yes. Is this what we're doing?
Yeah.
You should just give us worksheets now.
Well, you don't have a worksheet today. You have a book. Oh, that
I
one.
have a worksheet.
Okay. Excuse me. Excuse me.
I checked it when I was
Okay.
earlier.
You don't want to keep working with them?
No. What was the range on the last one?
Greater than or equal to 7
Okay.
because that K. You think you guys are good?
Yeah.
Okay.
Can I put it in an iPod?
Let's wait. Well, did anything happen to it? Left, right, up, or down? It's A. So 3 is A. Okay, now what's the difference? I'm asking you guys because we didn't get to that because you're just like, oh, we're done with notes. What is this negative reflected over? Which axis? The x-axis. So this is the x-axis. So which one is reflected over the x-axis? C. So this one is the what axis?
The Y.
The y-axis. So that would be what?
Bless you.
That'd be this one, wouldn't it?
Yep.
So that's 5?
Yep.
So now on this one, you're just going to do match again. And then you're going to determine domain and range. And then this one on 3, you're going to go through the steps you would to solve them. Okay? So I expect that done.